There is a process running in your arteries right now, and it started a long time before you were old enough to worry about it. By your late teens, the first fatty streaks are already there. By 40, in most people living the way you live, there is measurable calcium in the vessel walls. This is treated as normal. It is not normal. It is normal for us. In the Bolivian Amazon, there is a group of about 16,000 people called the Tsimané. They farm a little, they fish, they hunt, they walk. In 2017, a research team put 705 of them into a CT scanner and looked at their arteries. 85% of the Tsimané over 45 had no coronary calcium at all. None. In an American sample of the same age, that figure is around 14%. The average Tsimané in their 80s had the vessels of an American in their 50s. So what exactly do we have that they do not? And what did they have that we would never accept? Every layer of this gets stranger than the last, and the last one is on your plate. Let's go. Let's start with the list of things that we're missing, because the missing list is longer than you would guess. Start with blood pressure. In every industrialized country, blood pressure climbs steadily with age. That climb is so consistent that medicine treats it as a law of biology. Among foraging and forager farming groups, it does not happen. It stays roughly flat across the whole adult life. A Yanomami elder and a Yanomami young adult have similar readings. The salt number underneath that is worth hearing. Yanomami intake sits at roughly 1 gram a day, most of it whatever the food brought with it. In a wealthy country, the figure runs 9 to 12 grams, and almost none of it comes from the food itself. It comes from the processing. The kidney is a very good machine for holding on to salt when salt is scarce, which describes every environment our kidneys were built in. Then teeth. Look at the mouths in a hunter-gatherer cemetery, and the rate of cavities sits at a couple of percent, sometimes lower. That is not a nice smile. It is close to a different species of mouth. Their teeth wear down flat from grit and tough food. They crack, but they rarely rot. That number moves twice in history, and both moves are traceable in the same mouths. The first jump comes with farming, when ground grain arrives and sticks between teeth. In some Neolithic cemeteries, the caries rate climbs several-fold over the foragers who lived in the same valley a few thousand years earlier. The second jump comes with cheap refined sugar, which is very recent indeed. Hardened dental plaque preserves the DNA of the bacteria that lived in the mouth. And when researchers read that record across thousands of years, they see the community inside the mouth reorganize at each of those two moments. The mouth is not just accumulating damage. It has been colonized twice by a different set of tenants, both times because the menu changed. Then the bones themselves. The interior of a bone is a lattice, and how dense that lattice is depends on how hard the bone gets loaded during growth. Compare the joint surfaces of foragers with those of farmers, and then with ours, and the lattice thins at every step. The largest drop lines up with the move to farming, not with anything genetic. A modern hip is a noticeably lighter piece of engineering than a forager hip from the same species. Then eyes. Short-sightedness is close to absent in foraging populations. In some East Asian cities today, it runs above 80% of school leavers. Nothing about the eyeball changed genetically in 60 years. What changed is where the eye spends its first decade. Indoors, focused close. Then the whole immune column of the list. Asthma, hay fever, eczema, food allergy, type 1 diabetes, celiac disease, inflammatory bowel disease. In foraging populations, these range from rare to essentially unrecorded. In wealthy countries, several of them have been climbing for decades at a pace no gene pool can move at. There is a pattern in that column worth noticing. All of these are the immune system attacking something harmless. A peanut, some pollen, the lining of a gut, an organ. Not an infection getting through, the defense firing at nothing. And then the big ones. Type 2 diabetes, essentially absent. Obesity, absent. The specific cluster that fills modern clinics is simply not on the list. Before we go further, there is a detail in the Tsimané data that breaks the diet argument people usually reach for. Their diet is roughly 72% carbohydrate. Plantain, rice, manioc, corn. If refined carbohydrate alone drove hardened arteries, these would be the worst vessels on the planet, and they are the best ever measured. Fat makes up about 14% of what they eat, protein the rest. What is different is everything around the food. They spend somewhere near 90% of their waking hours doing something physical or moving. Step counts run around 17,000 a day. Sitting still is not a lifestyle option there. It is what you do when you are ill. And here is the part that should confuse you. The Tsimané carry a constant load of infections and parasites, and their blood shows high inflammation because of it. Chronic inflammation is supposed to drive hardened arteries. They have the inflammation and not the hardening. So the simple story fails twice over. It is not the carbohydrate, and it is not the inflammation on its own. Now, before this turns into a story about noble savages living in perfect health, hold on, because the other list is real, and it is brutal. They had infections we have forgotten. They had parasites, most of them permanently. They had injuries that stayed with them, joints worn out by 30, and any wound that turned bad was a serious problem with no reliable answer. And here is where the evidence gets uncomfortable for the romantic version. Take the frozen man found in the Alps, 5,300 years old. His stomach carried Helicobacter pylori, his gut carried whipworm. He had worn joints and hardened arteries at around 45 years old. So even a man walking 20 kilometers a day on a mountain diet had plaque in his vessels. Something else is going on, and it takes the rest of this video to unpack. The same thing shows up in Egypt. A team led by Randall Thompson took a CT scanner to 137 mummies from 4 different ancient cultures: Egyptian, Peruvian, ancestral Puebloan, and Unangan. Roughly a third of them showed probable or definite hardening of the arteries. These are people with no processed food, no cigarettes, and no chairs. Read that again because it takes the easy answer off the table. Arteries harden in humans. It is not purely a modern invention. But there is a pattern hiding in those numbers, and it is the pattern that matters. The mummies were mostly elites. Egyptian priests and officials ate the richest diet of their society, heavy in bread and beer and fatty meat, and they did the least physical work in their society. The Tsimané are the opposite on both counts. So put the two lists side by side because their shapes are completely different. Their list is fast and it comes from outside. An infection, a parasite, a wound that turns bad, a bad season. Things that arrive, do their work quickly, and are either survived or not. Our list is slow and it comes from inside. Arteries that thicken over 30 years. A pancreas that gives up gradually. An immune system that turns on a peanut. Nothing arrives from outside at all. The body simply runs its normal program for decades in a setting that program was never written for, and the result accumulates. That difference in shape is the whole story, and it points at a cause that has nothing to do with germs. And the same project found something else, on the other end of the body. The Tsimané were scanned again, this time for brain volume. Brains shrink with age in every population that has ever been measured, and the rate of that shrinkage in wealthy countries is treated as the baseline of normal aging. The Tsimané rate came out around 70% of it. Their brains age more slowly, alongside the arteries that feed them. Nobody thinks this is genetic. The most obvious candidate is the same one as everywhere else in this story: what the vessels are doing, what the body is doing all day, and what arrives on the plate. There is one more thing on the missing list, and it is the strangest of the lot. Almost every person in a foraging group carries worms, permanently. That sounds purely like a cost, and mostly it is. But a gut worm survives by quietly calming the immune system around it, because an immune system at full alert would remove it. For hundreds of thousands of years, our immune calibration happened with that hand permanently on the dial. We removed the worms in about 3 generations. Nobody thought to ask what else the hand had been holding. Which brings us to the sentence this whole video is walking toward. You were not designed to be fed this well. Not this reliably, not this softly, not this often. Every organ in you assumes an interrupted supply and a body that has to go and get it. Take away the interruption and take away the going, and the same organs behave differently. Not because they broke, because the input changed. So what did the input used to look like? The Hadza in Tanzania get around 100 grams of fiber a day. The average person in a wealthy country gets 15. That is not a small difference. That is a different organ system being fed. The bacteria in a Hadza gut swing with the seasons, blooming and collapsing as the food changes, and the diversity of species in there is far higher than in ours. And there's a strange result waiting in the middle of all this movement, one that ruins the obvious conclusion. In 2012, a team measured the total daily energy expenditure of Hadza adults using doubly labeled water, which tracks exactly how much energy a body actually spends, rather than what a step counter estimates. The Hadza walk far more than we do and do far more physical work. Their total daily expenditure came out about the same as ours, once body size was accounted for. That is not a mistake in the measurement. It looks like the body holds total energy spending inside a fairly narrow band and reallocates what is left over. Move less, and the body does not simply bank the savings. It spends them elsewhere, on inflammation, on stress responses, on processes that are useful in small doses and corrosive when they run all day. So the difference is not that they spend more fuel. The difference is where the body sends it. Food came with work attached. Tubers had to be dug out of hard ground. Honey had to be climbed for. Meat arrived after hours of walking, and often did not arrive at all. Every calorie carried a price in movement, and the price was not optional. And the supply stopped. Regularly. Not as a wellness practice, as weather. A body that expects gaps handles gaps well. Then, 12,000 years ago, in a handful of places at roughly the same time, people started planting. So what took it away? The answer is simpler than you would like: the harvest. Farming is usually told as the story where everything gets better. The skeletons tell a different story, and they have been telling it since the 1980s, when George Armalagos and his colleagues gathered the paleopathology from populations around the world that made the switch. The pattern repeats on almost every continent. Height drops, in some regions by up to 10 centimeters. Cavities climb steeply because ground grain sticks to teeth and feeds the bacteria that live there. Signs of iron deficiency appear in the bone. Growth arrest lines, the marks left in a bone when growth stops and restarts, become more common. Skeletons show more infection, not less. The individual sites make it concrete. At Abu Huraira in Syria, the skeletons of the first farming women carry a signature set of injuries: damaged toe joints, worn knees, and deformed lower vertebrae, all consistent with hours a day kneeling and rocking forward over a grinding stone. Grain has to be ground before anyone can eat it, and somebody had to do the grinding. That is the shape of the new bargain in a single body. The forager's skeleton is worn by walking and carrying. The farmer's skeleton is worn by repetition in one position, which is a much more modern kind of wear. Then the animals arrive, and with them the second wave. Living in a permanent settlement next to a herd is an efficient way to trade illnesses with another species. Measles is closely related to a cattle virus. Influenza cycles through birds and pigs. Tuberculosis walked in with the herds and the crowding. And crowding is the key word. Measles needs a population of something like 250,000 people in contact with each other to keep circulating at all. Below that, it sweeps through everyone available and then vanishes. A band of 30 people on the move cannot host it. A city can host it forever. So the first bargain was this. Storage and settlement bought reliability. More people per square kilometer, and something to eat next winter. The price was a narrower diet, a permanent exchange of illnesses with the animals, and enough neighbors for a crowd disease to survive. That bargain ran for 10,000 years. Then, very recently, we changed the terms again. Now the price, in numbers, because this is your body we are talking about. Sugar consumption in a wealthy country runs somewhere in the region of 30 to 40 kilograms per person per year. For most of human history, the annual figure was whatever honey a person could find, and finding it involved a tree and a lot of angry insects. Salt went the same way. Physical work went the other way, and the food got soft. Modern flour and modern processing hand the gut a meal that has already been half digested by a machine. And we know it is the processing itself, not just the ingredients, because somebody finally ran the trial properly. In 2019, a team took 20 volunteers and kept them in a research ward for a month. 2 weeks on ultra-processed food, 2 weeks on unprocessed food. The two diets were matched for calories on offer: sugar, fat, fiber, and salt. Everyone could eat as much as they wanted. On the ultra-processed weeks, people ate about 500 calories a day more and gained weight. On the unprocessed weeks, they ate less and lost it. Same people, same nutrients on paper, opposite results. The eating was faster on the processed food, which is the leading suspect. That is a controlled experiment on the exact question, and the answer is that a machine doing part of the chewing changes how much a person eats without them deciding anything. Your body reads all of that as a permanent good season. It responds exactly as it was built to respond to a permanent good season, by storing, by building, by settling in for the winter that never comes. We traded a body that wore out fast for a body that rusts slowly, and most of us never even noticed the exchange happening. Now some of you are thinking, hang on, they were all gone by 30. Whatever else was going on, we win on the only number that matters. Fair question, and the answer is in how averages work. Life expectancy at birth in a foraging population sits somewhere in the low 30s. That number is real, and it is almost entirely made by the first years of life. Averages are brutal that way. If a large share of a group does not make it past the first few years, the mean collapses, and the mean tells you almost nothing about the adults. So look at the adults instead. Michael Gervin and Hillard Kaplan did exactly that, pooling data across foraging and forager farming societies. Someone who reached 15 could expect to see their 60s. The most common adult age at the end of life sits somewhere between 68 and 78. Sit with that for a second, because it rearranges the whole picture. There were old people. There were grandparents. The image of a species that never got past 30 comes from an average, and the average was measuring something else entirely, which means the comparison is not modern old age against ancient youth. It is modern old age against ancient old age. And in that comparison, our advantage is narrower than it looks, and lives almost entirely in the first few years of life, and in infection. There is a second piece of evidence for the mismatch idea, and it does not come from bones at all. It comes from a border. In 1989, an epidemiologist named David Strachan noticed something odd in a British birth cohort. The more older siblings a person had, the less likely they were to have hay fever. More exposure to other people's germs early on, less allergy later. That observation became the hygiene hypothesis, and it has been argued about ever since. The sharpest test of it sits on the line between Finland and Russian Karelia. The people on both sides are closely related, sharing the same ancestry and the same forest. What differs is the standard of living, sanitation, and household environment. Type 1 diabetes runs several times higher on the Finnish side. Allergy rates in the same comparison run several-fold apart. Same genes, same trees, different microbial world in the first years of life, and a different immune system afterwards. That is about as close to a controlled experiment as human biology allows. What if the ache in that comparison is not damage at all? What if an immune system that has never met a worm, a farm animal, or a mouthful of soil is simply idle, calibrated for an enemy that never showed up and left with nothing to do? That is exactly what the old friends version of the idea says. The immune system does not just fight organisms, it is trained by them. And much of that training was scheduled for a childhood that no longer happens. Our ancestors, incidentally, were not passive about any of this. They had a pharmacy and they used it. Dental plaque is the unlikely hero here. Hardened plaque preserves DNA from whatever was in the mouth, and in 2017, a team pulled it off Neanderthal teeth from El Cidrón in Spain. One individual had an abscess in his jaw and a gut parasite. In his plaque, they found poplar, which contains the natural compound behind aspirin, and traces of the penicillium mold. A Neanderthal with a bad tooth was chewing painkiller and mold. That is not proof of intent, and the researchers said so. It is still a remarkable thing to find in a mouth from 50,000 years ago. The frozen man from the Alps carried birch polypore fungus in his kit, wrapped and portable, which happens to be effective against exactly the parasite he was carrying. And their approach to injury shows the same practical streak. Honey was used as a wound dressing across the ancient world, and modern hospitals came back around to medical-grade honey in the last few decades because it draws water out of bacteria and produces peroxide slowly. None of this was medicine as we know it. All of it was somebody paying close attention over a very long time. So where does this leave you, sitting still, with a body that is being fed better than any ancestor ever managed? Not with a fantasy about going back. Nobody in the Tsimané data is choosing that life for the arteries. They accept a childhood risk that would be unthinkable to us. They carry parasites, and they would take antibiotics in a heartbeat, which is exactly what they do when the clinic boat arrives. The honest picture is a swap. We took the infections and the childhood risk off the table, which is the single greatest thing our species has ever done. In their place, we put a permanent good season, a soft food supply, and a body that no longer has to go anywhere. The diseases that fill our clinics are not signs of a broken machine. They are the machine doing exactly what it was built to do, in conditions it was never built for. You have a body assembled for interruption, movement, and dirt, running in a world with none of the three. Most of what we call chronic illness lives in that gap. And that process in your arteries, the one that has been running quietly since your teens, is not a countdown. In the Tsimané, it barely runs at all, and nothing about them is genetically exotic. They are simply living closer to the conditions the vessel was designed around. So here's what I want to know from you. Which one would you actually take? Their list of diseases or ours? Tell me in the comments, and tell me which item on our list you would give up first.